Hi guys. So in this video we're going to start encapsulating even further to generate a new type of node. We did this before, but now now that we have a little bit of basics, we can start making nodes that are a little bit more smart. So we saw the function solver ik, and then we saw the function solver ik. So sorry, solver fk and solver ik. And these are atomic functions and they can work on their own. Then we saw the solver pull vector, which is used in conjunction with the ik. And now what we're going to do is we're going to make the rig graph very simple to read. You can see that this is where the encapsulation start working really nicely, because now this graph is very simple to read because the node that we are encapsulating one within another are becoming more powerful and more intelligent. So you can see here that I started adding, even if this it's a video about the leg module, which is not done by the way. We can start talking about solver AKFK anyway. I started adding these controls for the ARM, and this is my unit test kind of thing, where I'm writing code that I want to be generic enough so it can be reused. So let's see what we have here. We have solver fkik, and now we have this new function, and this function basically encapsulates both of them. So let's have a look. We have in the solver ikfk, we have basically every input as we did the last time in a few videos ago, and then all the new inputs that I added in the IK, and on top of that I have the setup mode, the orient IK controls, orient FK controls, and then these two that actually I don't need. These were me testing something, and then of course the switch. So how do we use this now? Basically this is the input function with all the inputs. If we look through what's happening, we have a sequence. The first sequence is checking if we are in setup mode. Setup mode, we can say setup mode. Are we in setup mode? Yes. Then, very easily, we say solver IK in setup mode, solver FK in setup mode, and plug the inputs. As simple as that. The more we make graphs that are smart, the more it becomes easier and easier to encapsulate them, to the point that the rig graph becomes simple to read and maintain. So we have the solver FK have items, and these items come directly from the input. So we have start bone, mid bone, end bone, IK control, FK control. What happens if we are not in setup mode? Then it means that we are in we need to check if we are in IK or FK. So there's another condition which is called switch. So in this case, if the switch is set to true, we are solving in IK. And as you can see, this becomes really simple to work with, because this node here is just a duplicate of that. But the only difference is that we are not in setup mode. All right? Both of these have the option to orient controls or not. And in this specific instance, if I travel back to the rig graph, I don't want the orient controls for the IK, but only for the FK, like explained in the previous video. So if we are not in setup mode, and we check if we have the switch, so here we can type IK or FK. So true, we are in IK, and then the solver FK needs to follow. What happens if we are in FK? So this condition is false. Well, it's exactly the opposite. I took that node, duplicate it here, put it to follow. So I want the IK to follow, and the solver FK is not following anymore. It's not in setup, and it takes the input that we described in a couple of videos ago. And that's pretty much it. So when we go back to the rig graph, this is my setup event. I specify all my inputs, I type them here, I specify how much distance I want. I want the controls to be IK to be aligned to the world, but the FK controls to be aligned to the bones. And then I have a switch. And then I can also specify the stretch. The stretch attribute is simply connected to the stretch attribute of the IK solver that we described in the last video. So on top of that, so this is the setup event. My controls gets populated. On top of that, we are running a function. Let me take that out for a minute and let's compile. So at this moment, I have solver IKFK. This is just a duplicate of this one, same values with IK stretch on because that's what I wanted, and is not in setup mode. And these are not, we don't need to specify these because we're not checking these if the setup mode is off. And of course the switch is driven by a control that says IKFK switch. So this will drive these attributes that are inside here. It's this condition here. Great. On top of that, I wrote a utility function that I'm going to start using all over the place. And this is a very basic utility function that flip-flops controls visibility. How does this work? It takes two collections, an FK collection and an IK collection of controls, and it flops between the two, meaning that if the visibility on one collection, the visibility off is not on, so is negating this attribute, this boolean, and is turning off the other one. So by toggling this condition here, you're basically either hiding one or the other, and vice versa. And of course, this condition is assigned to the IKFK control. So when I'm switching between IK and FK, also the visibility of the controls is switched. We saw this again, but now we are getting more familiar with function. Everything should be a little bit more consistent. So let me put that back in. You can see that the switch is definitely set to IK. We are in IK. Cool, amazing. And then we select the leg IKFK. And then we turn this off. Boom, we're back in FK. So this, let's say this concludes pretty much everything that has to do with the main kinematics. There is something I have not shown yet, is not implemented yet, and this has to do with what we call, like what the industry call nowadays, reverse foot. And the idea is that when we are in let me go back to IK. When we are in IK, you can see seamless toggling is preserving the position. When we are in IK, we want controls here that drives also the position of this IK handle up and down. So we can roll from this position or from the bolt position in the middle. We're going to look at that in the next video. But before jumping on that and finishing off the leg module, I want to start as an exercise, and it's something I keep doing over and over again, and it's something I thought it was worth sharing. The way I'm developing this node is that I constantly check that a completely different scenario should still work, so this node can be adaptable. I just want to double check. I just realized, yes, the stretching works. Great. So let's compile again. It's going to reset everything. So how do we test these now? So the thing I've done in order to test it is that I can see in the setup mode, I simply duplicated this, and I changed the names here accordingly to the bones that make sense in this case. So I would have put like upper arm L, lower arm L, etc., and so on and so on. So I've done this already. These nodes are actually here. It's just not to waste much time. So let's get rid of that. So let's put this, in this case, it doesn't matter if it's before or after. It's just a setup mode. And connecting it. These would pop in place if these were at the origin, but it happened to be that they were already in the right place because previously I connected this to test it. So both of them are in setup mode, and both of them have ORIN controls on. for FK, and you can see that the only difference, it's really these attributes here. These are bones, controls, and bones and controls with a different pole vector, because I thought that visually 10 would make more sense for an arm, so it's this distance here. So this is done. We're done. We're basically done for the IK, FK for the arm. And now same thing below. I would take this, connect it. So wait, before doing that, let me disconnect it. This thing, it's only for control placement because we are in setup mode. Now, in order to connect the rig, we need to be in the forward solve mode, right? So what I would do is I would connect this, and I would remove the setup and this one. And this happens to be something that it was here already. I prepared that already. Let's compile. Actually, I want to turn on the stretch. So if everything worked fine, we should see no difference here. But now we can see that the rig is connected. Now in this case, you can see that the IK controls are following, and the IK handle is positioned procedurally based on the angle. We can change this distance here. This is like the actual distance. Let me recompile that. And that's pretty much it. The last thing I want to show is that this function, again, because we embedded a function and we made it generic enough, we can make another one, which happens to be here, where instead of high flip-flopping between the leg controls, we can flip-flop between the arms controls. So we have the control IK, FK for the arm. We have the function. Let's connect this function. And then we have the collections. These are both all the IK controls for the arm and all the FK controls for the arm. And that's pretty much it. So if everything has by what I'm showing here again and again, and I know I'm repeating myself, is that now, because we are capable of quickly editing these and these are becoming nodes that are truly adaptable to any kind of skeleton. Let's say you have a biped that has completely bone names or a structure. You can adapt these nodes very quickly, and they should be consistent across the board and basically just work on top of, you know, placing themselves. So before we end this video, I just want to make a quick recap, because I realized that in my brain everything is clear because I built the graph. So from now on I want to start, you know, recapping every kind of function, because I realize that, you know, encapsulating function within functions can be a little bit daunting at the beginning. But let's see if I can make a recap of it. So we start with the simple projection. So we have a simple projection that goes and makes sure that I'm performing a project to new parent, but in the end I'm gonna it's only using one node instead of having these graph repeated all the time. So if I go, for example, in the solver FK, I'm using simple projection and simple projection. So let's try and see if I can explain this visually. So we have a simple projection. Let me bear with me. We have simple projection is a function. And this function, let's put it like that, this function exists inside, for example, the solver FK. So I'm using it inside the solver FK. So we can put a function solver FK. All right. Then let's look at the solver IK. In the solver IK, I'm using the function solve pole vector, for example. So if we go back to this one, I can have solver pole vector. I'm trying to say green are the utility functions. So, and here is in the solver IK. Now the solver IK is now being used inside the solver IK and FK. So both the solver IK and the solver FK have been used. So we can say that this becomes an even bigger solver, and this is called solver. Solver IK FK. All right. So I'm hoping that you can see where this is going. If we go into the rig graph, I'm using the solver IK FK, and that's pretty much it. Then we have an additional function here. Let me go back to this. An additional function that helps me say control visible flip-flop controls. And this is an atomic function that is used to drive the visibility of certain controls. Okay, so in the graph, in the high-level graph, this is what I mean by high-level graph, right? So in this graph here, this is the actual rig graph. This is how you would read from a high-level perspective. So we start from the high level and then we go deep down into the micro functions. So this way is from macro to micro, and this way is from micro to macro. Now, why is this important and why I'm stressing so much about it? It's because all these functions here, everything, this one, can be reused on their own. And I don't have to rewrite them every single time. I can literally call them in any other graph. And this is why it's so powerful. So much that I am missing, and we're going to look at later on, an additional square that I'm going to pick, like this color here. In reality, what I want to do, instead of using solver IKFK directly into the rig graph, I want to encapsulate that even more into something that I will eventually call, for example, leg module, where the leg module implements the solver IKFK on top of the foot and reverse foot. Same goes for the arm module. The arm module, as we remember, also implemented the hands and the fingers, but we haven't seen that now, right? So in here, I was just testing that both solvers work in different scenarios. So again, this is the main reason why encapsulating is a good thing, because I can use these functions on their own or within a much bigger context. And to maintain this is usually much better because you can reuse the code. You can more and more optimize this thing, and because this function or this function has been used everywhere, you're actually multiplying your efforts and optimizing the code everywhere you have used that function. This is true not just for control rig. This is true for everything, everything related to programming or visual programming. Of course, there is some sort of limit where you can nest function within function so much that it becomes so complicated. But in this case, that's not still the case. I'm talking about, a level of depth of 20 functions within function might become a little bit problematic. In fact, we're going to try to keep it maximum at this level. So to put ideally if I change this for a minute, so what I would love to have is my rig graph that says arm module, arm, leg, spine, and that's it. That's your high-level graph. And the fact that this still works, there will be function that I'm using here, and here, or everywhere, that I can constantly call back instead of rewriting them for each module. And also keep in mind that the way we're assembling these are to be adaptable, meaning that, you know, if you build a really nice arm, then you can have more than one arm, as we saw in the previous example. So all the examples I've done before this one were a simple way to start introducing, you know, the idea of functions, etc. But from now on, we're going to start building something that is a little bit more robust and consistent, and a little bit more with more features, basically. So that's pretty much it. Next video, we're going to keep going with the leg, because as I said, we are missing features, the features I described in the very first video. I'm very aware of that. See you next time.